Okay, so exponents and radicals. Basically, an exponent is anything that looks like this. So for example, you have a cube. A is referred to as the base, and the 3 over here is referred to as the power, or the exponent, right? So for example, if I say 2 cubed, so 2 is the base, and 3 would be the exponent, or the power, which actually means 2 times 2 times 2. So it's 2 multiplied by itself 3 times, right? Which is 8. So 2 cubed is 8. Now there are some laws that you need to know. We have the first one, which is any base to the power of 1 is going to be itself. So for example, 3 to the power of 1 is going to be 3, right? Then we have x to the power of 0. So anything to the power of 0 will always be 1. So for example, if you have 1729 to the power of 0, that has to be 1, right? That's going to be a 1. Next, x to the power of m multiplied by x to the power of n is xm plus n. So when the bases are being multiplied, you have to add the powers. So for example, if you have 2 cubed multiplied by 2 to the power of 2, 2 squared, that's going to be 2, 3 plus 2, which is 2 to the power of 5, right? So when you multiply the bases, you have to add the powers. So the next one, for division, you just have to minus. It's the same thing, but you just subtract them. So for example, if you have 2 to the power of 4 divided by 2 to the power of 1, that's going to be 2 to the power of 4 minus 1, which is 2 cubed. Next, if the power is being multiplied, right, like this, so x to the power of m, and then you have power n, you just multiply them together, right? So for example, 4 to the power of 3, and then you have 2, that's going to be 3 times 2, which is 6. Then you have xy to the power of m. Basically, in this, you just separate the powers. So this means x to the power of m and y to the power of m. It's like factorization. So for example, if you have, let's say, 2 multiplied by 3 to the power of 2, that means 2 squared multiplied by 3 squared. Next, we have it with division. So it's the same thing, but with division. So 2 over 3, and let's say, for example, 2. In this case, it's going to be 2 squared divided by 2 cubed, right? And then if you have a negative exponent, all you have to do is you have to change it. You have to bring it down. So you have to find the reciprocal. That basically means if, for example, you have 2 to the power of negative 1, you make it positive, right? So it becomes plus 1, and then you just bring it down in the denominator. So like that. So you go from here to here, right? So again, for example, let's say you have 3 to the power of negative 2, change it to a positive value, so it's 3 squared, and then just flip it. You get 1 over 3 squared, right? So that's what this is equals to. Okay, those are the laws. So here are some questions. In this case, you have negative 1 to the power of 4. That means negative 1 times negative 1 times negative 1 times negative 1. This is 1, this is 1. So 1 times 1 is 1. If the power is an even number, it's always going to be positive, right? So in this case, because it's odd, 5 is an odd number, I know it's going to be negative 1. 10 is even, that's going to be plus 1. 15 is odd, so that's negative 1, right? And so on. In this case, for example, you have negative 1 to the power of 8. Another way to write this is negative 1 is negative 1 to the power of 8, right? So you separate the negative sign. This is negative, so you solve this part first, which is 1 to the power of 8 is 1, and then you still have the negative sign here, right? The negative is not part of the 1. The 1 is separate. In this case, we solve the bracket first, so negative 1 to the power of 8, we get 1, and then we still have this negative outside, right? So that's negative, and then we solve this, which is 1, so negative 1. In this case, we have negative 3 cubed, which means negative 3 times negative 3 times negative 3. This is 9 times negative 3, which is negative 27, right? And then again in this, the negative is outside, which means we solve this first. So you have negative 27, so minus 27, right? Easy. We have some more questions. Let's see. So this is going to be 1, because anything to the power of 0 is 1. This is going to be 6 to the power of negative 1, which means you change it to a positive value, right? So it's 6, 1, and then you just flip it, so it's 1 over 6. Same with this, it becomes 4, and then 1 over 4, right? Next, let's try this one. So that's 5 cubed, and then you bring it down, you get 1 over 5 cubed, which is 1 over 125, right? And then let's just try this one. So negative 1 to the power of 4, because it's even, it's going to be 1. 3 cubed is 27, and then times 4. So this is going to be 80 plus 28, it's 108. Yes. Alright. Next. Here's some more questions. So let's say, for example, you have this. So this means always multiply the numbers first. So we have 3 times 2, which is 6. And then you have x to the power of 2 and x to the power of 3. Because they're multiplying, you have to add the powers. So 2 plus 3 is 5, right? So with this one, it's 2 times 4, which is 8. And then k to the power of negative 4 and k to the power of 2. We just add them because it's negative. It's being multiplied. The bases are being multiplied. So it's minus 4 plus 2, which is k to the power of negative 2, which another way to write this is k squared. You change it to k squared, and then you divide by 1, like 1 over that. So 1 over k squared, right? So we get 2 times 4 is 8, and then 1 over k squared, which is why it comes down. Okay, next we have 5 times 3, which is 15, and then you have x to the power of 4 times x to the power of negative 2. Because they're multiplying, we have to add the powers, which means 4 minus 2. So it's actually 4 plus minus 2, which becomes 4 minus 2, which is 2. So you get 15 x squared. Okay, let's try this one, 6. So negative 3 times 3 is negative 9. A squared and a to the power of negative 5. So that means 2 minus 5, which becomes negative 3. So a minus 3, and then we have b minus 3 and b8. So that's b minus 3 and b8. So we need to add the powers. In this case, it's like saying minus 3 plus 8, which is 5. So we get b5. Right? That's what it's going to look like. Then let's try this one. So we solve the brackets first. We have negative x cubed, which because the power is odd, we get negative x for this. That's negative x. And then we have a negative outside as well. So this negative, that's here, which becomes plus x, right? So negative becomes positive. Let's try this one. So in this we have the power outside the brackets, which means you have to multiply this by 3, to the power of 3, and this by power 3, which means x to the power of 2 times 3 and y to the power of negative 1 times 3, which becomes 2 times 3 is 6, and negative 1 times 3 is negative 3. And another way to write this would be, we can make this positive, so that becomes x6 times 1 over y cubed. So you can write it as x to the power of 6 divided by y cubed. Let's try this one, 16. So because you have the same bases and it's being divided, which means you have to subtract the powers. So x 3 over 2 minus 1 over 2. So 3 over 2 minus 1 over 2 is 2 over 2, which is 1. So it's actually x to the power of 1, or just x. Let's try this one. So in this we have b to the power of minus 2 multiplied by minus 3, So you multiply them. Minus 2 times minus 3 is positive 6. So it's b6. And then we have b power to the power of 3 times to the power of 2. So that's also b6. Right? 3 times 2, 6. So b to the power of 6 times b to the power of 6, which is going to be b to the power of 12, because we need to add the powers. 6 plus 6 is 12. In this case, we have 1 over x to the power of negative 2. So let's start with this first. This means 1 over x squared. So we can write this as 1 over x squared. And another way to write this would be 1 divided by 1 over x squared. Change the division to multiplication. You get 1 times x squared over 1, right? Which is just x squared. Right. Let's try this. So we have x to the power of 2 divided by x to the power of negative 3. So because they're dividing, we would have to minus the powers. So x2 minus 3. So we get 2 plus 3, which is 5. So x becomes 5. We have y3 and y minus 4. So it'll be 3 minus 4, which is 3 plus 4, which is 7. So that's y7. And then we have z to the power of 4, z to the power of 4, and z minus 5. So again, it's 4 minus 5, which is 4 plus 5, which is 9. So that's z to the power of 9. Next. Here's a question. We have this expression equals to y. They want 3 to the power of x in terms of y. So we need to find 3 to the power of x, right? 3 to the power of x equals what? Now, 3 to the power of x plus 2 can be written as the rule that we had for multiplication. So for example, it was a to the power of 3, for example, times a to the power of 2 gives us a3 plus 2. So basically, we're going backwards. We're going from here to here. So I can separate this by writing 3 to the power of x multiplied by 3 to the power of 2, which is the same thing as this, right? So x plus 2, because they're multiplying. And then this is equals to this, which is equals to y. So this equals y. They want us to find 3 to the power of x, which means we need to get rid of 3 to the power of 2. So it's 3 to the power of x. You can write this as 9 is equals to y. Because it's multiplying on this side, it would have to come on this side and divide. So it's like saying 3 to the power of x is equals to y divided by 9. Right? Because it's multiplying on the left side, which means on the right side it will divide. So that'll be your answer. Next. It says what's the value of a? In this case we have the bases are 3. So if the base is equal, we can make the powers equal as well. So you simply have to make this equal to this. A plus 1 equals negative a plus 7. So you bring this on this side, bring this on this side. So negative a becomes positive a on the left side. So it's a plus a. And then 7 plus 1 goes on that side, it becomes minus 1. You get 2a is equals to 6, which is 3. Next, it says 2a minus b is equals to 4. What's the value of this? So always look for a common base. So in this case we have 4 and we have 2. I can write 4 as 2 squared, right? So 4 I can write as 2 squared, and that's to the power of a, and this is just 2b. So this is the same as writing 2 to the power of 2a divided by 2 to the power of b. You can use the rule for this. So in this case, the bases are the same, and we're dividing, which means we have to subtract the powers. So it's 2a minus b. That'll be our answer. And actually, no. So this is equals to 4. 2a minus b is equals to 4, and we have 2a minus b, right? 2a minus b, 2a minus b. That's equals to 4, so you can substitute. You can write this as 2 to the power of 4, which is 16. Alright, next. A simple way to do these questions is use this rule. So you have x inside and outside. This is equals to x in divided by out, right? You can just learn this. So in this case we have 5 and 4. So 5 is inside, 4 is outside. You can write this as 5 over 4. Inside divided by outside. Alright, next. What's the value of x? We have roots. Anytime you see roots, it's always best to square them to get rid of them. So 4 root 3 is equals to root 3x. Square both sides. If you square both sides, you will get 4 squared, which is 16, and then root 3 squared, which is just 3, right? Because root 3 squared, it cancels out, so it's just 3. And then this is root squared, you can cancel this with this. So this is equals to 3x. Now you can actually cancel 3 and 3, which means x is equals to 16. Right, 16. Okay, next. We have radicals, we have to simplify these radicals. So to simplify, you need to find numbers that are perfect squares. So for example, you can write 12 as 6 times 2, or you can write it as 4 times 3. So now in this case, there is no, we cannot take a root of 6 or of 2, but for 4, we can take a root, so we'll use this. You can write it as 4 times 3. You can separate the roots, so you can write root 4 times root 3. Root 4 becomes 2, and then you just have root 3, so 2 root 3. That will be your answer. For the next one, we have 96. 96, we can write it as, let's see, 16 times 6. So this is the best way, the best number to choose, because 16 is a root. So you can separate this and write it as root 16 times root 6. So 16 becomes 4, so it's 4 root 6. That's it. 45, you can write as 15 times 3. Or you can write it as 9 times 5. So in this case, it'll be better to use this because 9 can be taken as a root. So root 9 times root 5, you get 3 for root 9 and root 5. Right. So root 8, you can write it as 4 times 2, which is root 4 times root 2, which is 2 root 2, because root 4 is 2. For these questions, you can square both sides again. So let's say, for example, you have this. So you square both sides, you get square of this and the square of this. So for the left side, it's 2 squared, which is 4. And then root 2 squared just cancels out. So it's just 2. And then this cancels out with this. We get 4x. You can cancel 4 on both sides, which means x is 2. Let's try this. So again, you square both sides, square of this, square of this. 3 squared is 9. Root of 14 squared is just 14. And then this cancels with this. You get just 6x. So you have 9 times 14 is equals to 6x. You can divide, you can write as 9 times 14 divided by 6. Simplify this. 3 times 2 is 6, 3 times 3 is 9, and then you get 3, 14, and 2. Simplify again. 2 times 1 is 2, 2 times 7 is 14. So you're left with 3 times 7, which is 21. That'll be x. For this one, you can square both sides, so square this, 3 squared is 9, root 8 squared is just 8, and then you have x squared, and root 2 squared is just 2. So you can bring the 2 down and divide on the left side. You get 9 times 8 over 2 is equals to x squared. You can simplify this, so 2 times 1 is 2, 2 times 4 is 8, 9 times 4 is 36, is equals to x squared, which means x is 6, right? And then for this one, we can square it again, so square this, you get x squared, and then root x squared is just x, right? Root x squared is just x because it cancels out, is equals to, and this cancels with this, so 216. This is equals to x squared, and then this is 1. So because they're multiplying, you add the powers, you get x3 equals 216. And then we need to find the cube root of 216. You take the cube root on both sides to cancel it out. Cancel. You get 6. Right. So for the first one, you have a negative 1 over 2 equals 3. You can write this as 1 over a 1 over 2, right? Because it's negative, you bring it down, and then 1 over the positive version. This is equals to 3. You can cross multiply. You can take this up, so you get 1 is equals to 3a1 over 2. You can bring the 3 down on this side, 1 over 3 a 1 over 2, and then to get rid of the 1 over 2, you can square both sides. Okay. So square both sides, and this will cancel with this. Cancel this, so it's just a on the right side. So this is actually equals to 1 over 3 squared is equals to a, which means you get 1 squared is 1, and then 3 squared is 9. You get 1 over 9. For the next one, you have it says what's the value of n? N is equals to this. So you have, it's 50 times, it goes up to 50, but it's only for the even numbers, which means in total, you will have 25 exponents, right? Like this, because we're skipping every number. So this is basically like saying 1 to the power of 25, which is also 1, right? Because it's going 25 times. So next one, we have this 4 2n plus 3 is equals to 8n plus 5. Find the common bases. So 4 can be written as 2 squared, and then 8 can be written as 2 cubed, and then you multiply the powers, you get 2. So 2 times 2n is 4n, 2 times 3 is 6, is equals to 2, and then 3 times n is 3n, 3 times 5 is 15. So now that we have the bases are equal, we can make the powers equal. So 4n plus 6 is equals to 3n plus 15. You can move their places. 3n comes here, 6 goes there. 4n minus 3n is equals to 15 minus 6. You get n is equals to 9. Next one. So we have 2 to the power of x divided by 2y. Because it's dividing, you can write it as 2 to the power of x minus y is equals to 2 cubed. So the bases are equal, which means we make the powers equal. So x minus y is equals to 3. You need to find x. So to find x, y goes there. X is equals to 3 plus y. So it's A. Next, we have 3 to the power of x is equals to 10. And then we have to find 3 to the power of x minus 3. So you can write this as 3x divided by 3 to the power of 3 because it's negative. Because it's negative, that means you have to divide the powers like that. So this is equals to 3 to the power of x, which is 10. 10 over 3 cubed is 27. You get 10 over 27. Okay, next. We have this is equals to 10 and this is equals to 8. What is the value of this? To get x to the power of 5, you can use x squared and x cubed. You can write this as x squared times x cubed is going to be x5. And similarly, y cubed times y squared is going to be y5. So if you multiply this with this, you will get this. So x squared y cubed, if you multiply with x cubed y squared, it'll be equals to x5 and y5. So this is equals to 10. This is equals to 8. And it'll be equals to that, which is 80. So this is equals to 80. It says a and b are positive even integers. Which of the following is greatest? So looking at the options, you have to the power b in the power and you have 2b, right? B and 2b. So to get the greatest value, you have to have the biggest power. So it has to be 2b, right? So it's either b or d. And then because the difference is that in d, it's only a to the power of 2b, not 2. So it's 2 multiplied by a 2b. But in b, it's negative 2a 2b, which means everything is multiplied by this power. So it's negative 2b and a 2b. So, and because it's squared, negative 2 squared, it becomes positive. So you will get this as the bigger value. So it'll be negative 2 or 4b and a 2b. So this is bigger than this. Okay, next one. So this is inside, this is outside. So 2a is inside, b is outside. That'll be the correct answer.